Okay, for number 89, the directions read, write the height of the rectangle as a function of x. Now, the first thing when you look at this actual drawing is, most of you aren't going to see the rectangle, you're going to see the parabola. So then it becomes a case of, well, if I have a parabola, what does that have to do with a rectangle? All right, so let's break down the directions a little bit here. We want to write the height as a function of x, okay? So if I translate that into function notation, I want to find the height as a function of x, okay? The name of my function is height. X is going to be the variable that I want for my input. Now, the equation that I was given was y is equal to negative x squared plus 4x minus 1. Right? That is the equation of the parabola that I've just highlighted in orange. So the question is, how does this information tell me anything about the height of this red rectangle? Well, for every one of these blue dots, the blue dots are ordered pairs that are solutions of the parabola, which means they're x and y values that make this equation true. Okay? So the key here is the fact that the height, which I've highlighted in green, this height is always going to be relative to the value of the blue dot and the green line. Okay? So what's interesting is that the parabola piece is only going to run between 1 and 3. That's what they've outlined for us. So while the parabola goes on forever to the left and to the right, we can only take the pieces from these two endpoints in order to have a height of our actual rectangle. So, looking at my equation, my blue point is always going to be the maximum highest value of the rectangle. Do I want the x or do I want the y value if I'm talking about height? I want the y value, okay? Because height is related to the y-axis, height. But even though I have that value, if I come all the way down the dotted line, the x and y value is going to be the total distance of the blue dotted line. How do I find the distance of the red? What do I need to do in order to always calculate that? That's the trick of the problem. How do I always find the red piece if I always know the dotted length? How do you find the red if I know the dotted length? Yes? Subtract out 2. So here's what I'm saying with that. If I take the y value, whatever it is, and I subtract out 2, doesn't that always give me the size of the red length? Does that make sense? Okay, so let's look up here. The height in red is the same thing as taking whatever the y value is and subtracting 2. This is ultimately the equation to talk about the red section that answers the question. There's only one problem with that. What is height in terms of? Y. I want it as a function of x. I want height as a function of x. So if I use this and say, okay, well the height is equal to y minus 2, what is y defined as in orange? It says it right above it. What is y? Y is what? Negative x squared plus 4x minus 1. But then at the end, I still need to write the minus 2. Combine like terms. Now do I not have an equation for the height in terms of x?